In this video, we examine a function in a complex variable and show that it is nowhere differentiable, or that its derivative does not exist anywhere. The function is the one that gives the principal argument of z, where z is a complex number and is denoted by uppercase arg of z. The principal argument of z is the argument of z that is greater than minus pi and less than or equal to pi. To show that the derivative of the principal argument function does not exist anywhere, we subdivide the set of complex numbers into three cases. Let z sub 0 be an arbitrary complex number. Then for case 1, we set z sub 0 equal to 0. Now, whatever the principal argument of 0 is, whether we leave it undefined as some people do, or we define it as some real number, the limit of the principal argument of z as z approaches 0 does not exist, so that the principal argument function is discontinuous at 0 and therefore not differentiable at 0. We can show that the limit of the principal argument function as z approaches 0 does not exist by finding two different approaches to 0 and showing that the principal argument of z approaches two distinct values along these two paths. We can, for example, approach 0 along the positive real axis as our first path. The principal argument of any complex number on the positive real axis equals 0, so that the argument of z tends to 0 as z approaches 0 along the positive real axis. On the other hand, z can be equal to I times y, where y is a positive real number, so that z approaches 0 along the positive imaginary axis, where every principal argument equals pi over 2. And so the principal argument of z tends to pi over 2 along this path. 0 and pi over 2 are of course not equal, so that the limit of the principal argument of z does not exist at 0, and therefore the principal argument function is discontinuous at 0. Therefore, the principal argument prime at 0 does not exist. For the second case, we have z sub 0 as a negative real number. For path number 1, let z be a negative real number so that its principal argument is always pi, so that as z tends to z sub 0, the principal argument of z tends to pi. For path number 2, we choose this time the quarter portion of the circle, the absolute value of z equals the absolute value of z sub 0 in the third quadrant. As z approaches z sub 0 along this arc, the principal argument of z tends to minus pi. And so we have two different values for the limit along two different paths, so that the principal argument function is discontinuous for negative real numbers. Therefore, the principal argument prime of z sub 0 does not exist if z sub 0 is a negative real number. Combining cases 1 and 2, we conclude that the principal argument prime of z sub 0 does not exist for negative real numbers and 0. The rest of the complex numbers comprise the third and final case. Let z sub 0 be neither 0 nor a negative real number. Let r sub 0 be equal to the absolute value of z sub 0 so that r sub 0 is greater than 0. Let theta sub 0 be the principal argument of z sub 0. Just as with 0 and the negative real numbers, we will approach z sub 0 along two different paths, but this time it's the value of the derivative of the principal argument function at z sub 0 that we will be examining. The first approach to z sub 0 is along the radial line from the origin through z sub 0. On this radial line, every non-zero complex number z has as principal argument theta sub 0, the same as that of z sub 0, provided that the origin is outside the segment between z and z sub 0. So the principal argument of z is constant along this path and therefore has 0 rate of change along this path. Therefore, the derivative of the principal argument at z sub 0 equals 0 along this path. On a somewhat related note, we can think of this derivative value as being similar to the directional derivative of a function, since we are looking at the rate of change of the function along a certain path or direction. For the second path leading to z sub 0, we choose the arc of the circle that passes through z sub 0 and is centered at the origin. This circle's equation is given by the absolute value of z equals the absolute value of z sub 0. Let z be on the circle, and let the principal argument of z be equal to theta sub 0 plus delta theta. Without loss of generality, we choose z close enough to z sub 0 on the arc so that 0 is less than delta theta is less than pi over 2. The difference quotient for the principal argument prime of z sub 0 equals the principal argument of z minus the principal argument of z sub 0 all over delta z. The principal argument of z is theta sub 0 plus delta theta. The principal argument of z sub 0 is theta sub 0. Theta sub 0 cancels out so that the difference quotient is delta theta over delta z. It might be tempting to say that delta z is the arc or the length of the arc between z sub 0 and z, but it is neither the arc nor the length of the arc between the 2 points. Delta z is actually the vector from z sub 0 to z, so that the absolute value of delta z is the length of the segment between z sub 0 and z. Let's take the absolute value of the difference quotient. We calculate the absolute value of delta z by applying the law of cosines on the triangle with vertices 0, z, and z sub 0. For the square of the absolute value of delta z, we have the sum of the squares of the lengths of the two other sides, each of which is a radius of the circle. So we have r sub 0 squared plus r sub 0 squared. Then we subtract twice the product of the two radii, so that we have minus 2 times r sub 0 squared. Then we multiply this by cosine of the angle opposite delta z. That angle happens to be delta theta. We factor out r sub 0 squared. Then 2 so that the absolute value of delta z equals r sub 0 times the square root of 2 times the square root of 1 minus cosine of delta theta. Therefore, the absolute value of delta theta over delta z equals this quantity. We multiply this by the square root of 1 plus cosine of delta theta over the square root of 1 plus cosine of delta theta. The product of these two square roots, with or without the absolute value, is the square root of 1 minus cosine squared of delta theta. This is equal to the square root of sine squared of delta theta. Since sine of delta theta is positive because we have delta theta greater than 0 and less than pi over 2, the square root of sine squared of delta theta is sine of delta theta. We put delta theta over sine of delta theta, and the rest in a separate fraction. We can also do away with the absolute value since delta theta and sine of delta theta are positive, so that we now have the difference quotient sans absolute value. As delta z tends to 0, delta theta also tends to 0. A basic fact from introductory calculus is that as delta theta tends to 0, delta theta over sine of delta theta tends to 1. Cosine of delta theta also tends to 1, and square root of 2 cancels out, so that the difference quotient tends to 1 over r sub 0. So the principal argument prime of z sub 0 equals 1 over r sub 0 along path number 2. This is not equal to the value 0 for the derivative along path number 1. So the derivative of the principal argument function does not exist for z sub 0 for case 3. Therefore, combining the results from the three cases, the principal argument function is nowhere differentiable.